Hello everyone. I hope you guys can hear my voice.
Yes, ma'am.
We'll wait for a few more minutes to let everyone join and then we'll start the session. everyone. I hope I'm audible to you all. Can someone confirm?
Yes, ma'am.
Thank you. I'm Bhagyashree Pradhan, and as part of my PMRF, I have this duty for this course, Drug Delivery Principles in Engineering. And in this session, we'll mostly solve previous year assignments that will help you in solving the current assignments as well as the upcoming exam that you'll give as part of the NPTEL course. And also, if you guys have any other doubts, that also we can solve during these sessions. In some time, I'll share my presentation. Let me know if you guys can see the screen. Is it visible to everyone if I make it full screen?
Yes, ma'am.
Since people are still joining, we'll wait for another 2 minutes. Otherwise, there will be more interruptions in between. So let's wait for another minute or two. Okay, so we'll start the session now. Welcome all to the first session for TA for Drug Delivery Principles and Engineering. In the last week, these were the topics that were covered. Drug delivery, an introduction was given, and then about pharmacokinetics, prodrugs, and polymers was introduced, and their synthesis and properties. So basically, it talks about the pharmacokinetics and pharmacodynamics. Throughout the course, we'll mostly focus on the pharmacokinetics aspect, which is basically the dosing regimen, when, how much should be given, what dose should be given, all of these aspects, and then different factors that affects these on the different factors that have effects on these drugs, maybe their solubility, their ionization, partition coefficient, etc. Different routes of administration and how it affects the bioavailability of these drugs, first pass effect, drug distribution in tissues and their eliminations, And then we talk about prodrugs and what they are basically and how they help in efficient delivery of drugs, followed by polymers, different types based on their structures, shapes, and their properties, and synthesis of these polymers by step or chain reaction. And then the course talks about the properties, basically molecular weight, polydispersity index, crystalline versus the amorphous nature, and the different temperatures. So based on these topics, there is a few questions, previous year assignment questions that we are going to solve. Please feel free to stop me anytime in between if there is any doubt. Should we move ahead?
Yes, ma'am.
Okay, so here is the first question. A prodrug can be, there are two options that are correct here: a prophylactic drug, a drug conjugated to enzymes cleavable by biological systems, the prototype member of a class of drugs, the oldest member of a class of drugs, an inactive drug that is transformed in the body to an active metabolite. Please let me know what you think the answer is, and I hope that all of you guys will participate throughout this discussion. Which of these options do you think is correct?
Ma'am, I think second.
Okay,
And fifth.
okay. Anybody else would like to answer?
I too think second and fifth.
Okay, what about others?
Second and fifth, ma'am.
Okay, yes, most of you are correct. The second option, that is drug conjugated to enzymes cleavable by biological systems, an inactive drug that is transformed in the body to an active metabolite. So basically, you can make the drug inactive either by conjugating it to another linker or some other inactive form, and then because of the enzymes in the body, these linkers could be cleaved and is available in the body for to be in the active form. So that is a prodrug. Moving on to the next question. Which of the following drugs are absorbed in the greatest amount? You have to select two correct options here. 100 mg of drug administered with a bioavailability of zero point 0.7, 150 mg drug bioavailability zero point 0.5, 200 mg drug administered with bioavailability zero point 0.4, 250 mg with bioavailability zero point 0.2, 80 drug administered intravenously, 80 mg drug administered orally, 20 mg given orally, and 20 mg given intravenous.
Ma'am, first and eighth.
First and eighth. Okay.
First and fifth, ma'am.
First and fifth. Okay. Anybody else would like to answer? into 1 and 8th. Okay. 3 and 5. Okay. Okay. Let's try to solve this. Sorry. Okay. So here 100 mg of drug is administered, but bioavailability is 0.7. So the amount of drug available actually here is 70 mg, right? And in this case, it's 15 into 0.5, basically 75. In this case, it is 80 mg. In this case, it is 50 mg. I'm basically multiplying the amount of drug administered into the bioavailability. And in this case, since it is intravenous route, the entire thing is available. So this is also 80 mg. This one is administered orally, uh, but not the entire thing will be available. Bioavailability is not given, so it will be slightly lesser than 80. And then again, same 20 mg and 20 mg given intravenous. So if you look across all the options, the third option has 80 mg and fifth option also has 80 mg. So basically these two will have the greatest amount of drugs that are absorbed. So option correct answer would be option 3 and option 5. 20 mg drug administered, 200 mg drug administered with bioavailability of 0.4 and 80 mg of drug administered intravenously. Okay, moving on to the next question. A new antiviral drug is administered intravenously, resulting in an initial plasma concentration of 12 mg per liter. After 9 hours, the plasma concentration is 1.5 mg per liter. Assume first order elimination kinetics and calculate the half life of the drug. Please try to solve. After I get few answers, we'll then solve it for everyone else together. Repeating the question, a new antiviral drug is administered intravenously, resulting in an initial plasma concentration of 12 mg per liter. After 9 hours, the plasma concentration is 1.5 mg per liter. Assume first order reaction elimination kinetics and calculate the half life of the drug. has already given one answer, 13.3. Okay. Here you have to use the formula Ct equals to C naught e to the power minus kT, which is the first order equation, and for half life T half would be 0.693 upon K. I've given you a hint. You can use this formula to calculate it, and then I'll solve. Anybody else who has solved it? Uh, Three other people have answered approximately 3 hours. Okay. All of you are correct. It's almost 3 hours. We'll now try to solve it here. So basically, we are going to use this first order equation, Ct equals to C naught e to the power minus Kt, where Ct is the concentration at time t, which is basically 1.5 mg per liter, and C naught is our initial concentration, which is 12 milligram per liter. T is here 9 hours, and K we have to find out. So this will be basically ln Ct, which is 1.5 upon C naught 12, and this will be equals to minus K is we have to find out, and T is 9 hours. So K is basically ln 1.5 by 12 by 9, which is approximately equals to 0.231, 0.231. Now that we have the rate constant, we have to put that in this to get the half-life of the drug, which is 0.693 upon K. So 0.693 upon 0.231 will give us 3 hours basically. So the correct answer is 3 hours. Okay, now moving on to the next question. The volume of distribution of a drug, or VD, is known to be 30 liters. How the drug is expected to distribute in the body? There are 8 options here: in total body blood, in total body water, everywhere in the body, only inside the cells, only on body fat, only in body muscle, only in brain fat, in fat of bone marrow. In total body water, option 2. Okay, please guys try to unmute. If not, then try to put in the messages, because I'm not getting notification and I don't know if you guys have already answered. Anybody else wants to answer? The volume of distribution of a drug is known to be 30 liters. How is the drug expected to distribute in the body? In total body blood, in total body water, everywhere in the body, only inside the cells, only on body fat, only in body muscle, only in brain fat, in fat of bone marrow.
Ma'am, in total body blood.
Body blood, okay.
Total body water.
Okay.
Ma'am, in total body water.
In total. Okay. Anybody else who wants to answer? Okay. So the correct answer here is in total body water. So in this kind of questions, there is no definite volume that is for any particular thing. There will be always an approximation, and the volumes for these tissues, blood or water is almost more or less similar. So if there is 8 to 10 liters of volume, that is mostly related to your blood or plasma. If it is around 30 to 50 liters, it is going to be in the water. If it is more than that, then it is going to be in the tissues and fatty tissues, mostly total body fat and other tissues. So since it says 30 liters, it falls in the near to the total volume of the body water. So the correct answer here will be option 2 in total body water. Okay. Moving on to the next question. Which of the following equations depict a second order reaction? You have to select two correct options here. Option 2. Okay.
Option 2 and 3.
Okay.
Option
Option.
second. 2.
But here you have to select two correct options.
Option 2 and 3.
Okay.
Second and third.
Okay. Anyone else?
Ma'am, B and C.
Okay. Okay, here also few people have answered B and C and 2 and 3. Okay. Yes, most of you are correct. Almost all of you are correct. It will be option B and 3. Here the first one is obvious, R equals to K, C1 and C2. It is a second order reaction. The second one, if you see, it's C1, C2 to the power zero point 0.5 and C3 to the power zero point 0.5. This will basically be uh, equals to C1 and your C2 plus C3, and the entire power will be to the power zero point 0.5. So here also basically only two components are there, so this will also be a part of second order reaction. So both option B and C are correct. Moving on to the next question, which one of the following will have ease of permeating through cellular membranes? Drug with higher partition coefficient and is highly polar, drug with higher partition coefficient and is not polar, lower partition coefficient and is not polar, drug with lower partition coefficient and is highly polar, hydrophilic drugs, highly charged drugs, or polar molecules.
Option 2.
Option 2, okay. Option 2, okay. Which one of the following will have ease of permeating through cellular membranes? Higher partition coefficient and highly polar, higher partition coefficient and not polar, lower partition coefficient and not polar, lower partition coefficient and highly polar, hydrophilic drugs, highly charged drugs, or polar molecules. Anybody else would like to answer?
Second, ma'am.
Okay. Okay. Yes, the correct answer is drug with higher partition coefficient and is not polar. The second option. For others, basically partition coefficient is basically your solubility of the drug in two different phases, in oil phase upon the water phase, oil by water. So higher partition coefficient, meaning it is more soluble in oil, and if it is non-polar, it will be more easily permeating through the cellular membranes, which are basically lipophilic. Okay, moving on to the next question. Bioavailability by definition is defined as which of the following options? AUC route by AUC IV, area under the curve IV by area under the curve route, 1 by AUC route. Okay. Which of the options define bioavailability?
Ma'am, first.
Okay.
Ma'am, first.
First.
Ma'am, first.
Okay.
Option 1.
Okay.
And first option.
Okay. Okay. All of you are correct. It will be the first option, where it is area under the curve for the route of administration by area under the curve for intravenous administration. And for intravenous, the entire thing is bioavailable. That is 100% bioavailability. Okay, moving on to the next question. This is another numerical. A 75 kg patient is administered a single intravenous dose of 280 mg of the drug X, a highly lipophilic compound, and after distribution equilibrium, the drug's plasma concentration is measured as 1 milligram per liter. What will be the volume of distribution of the drugs in liters? And based on this and typical body fluidic compartment, where do you think this is likely to distribute?
The apparent volume of distribution of drug X is approximately 280 mg.
I couldn't hear you. Can you please repeat what you said?
The answer is 280.
280. Okay. Okay. We'll wait for others to answer and then I'll let you know the correct answer. Anybody else? If a patient is administered 280 mg of the drug and after equilibrium the plasma concentration is measured as 1 mg per liter, what will be the volume of distribution?
Ma'am, 280.
Okay.
280.
Okay. What about the second part of the answer? I mean, second part of the question. Where do you think this is going to get distributed?
I'm in the blood.
In the blood. Okay.
Fatty tissue.
Okay. What about others?
In the
It's
blood.
stored in tissues. Body fat.
Okay.
Body blood.
Sorry.
Body blood.
Body blood. Okay.
No, ma'am, I mean blood.
Could you repeat again?
I mean body fluids like blood.
Blood. Okay. Okay. Anybody else would like to answer? Most of you are correct. The correct answer is 280 for the first part, that is the apparent volume of distribution of the drug. So here the question is volume of distribution. Volume of distribution is basically the total amount of drug, which is 280, and the concentration that is concentration that is measured in the plasma, which is basically 1. So the total amount would be 280 liters. And as I said in one of the previous questions, there are typical body fluid volumes for different compartments. It is approximately less than 10 liters, 8 to, or between 5 to 10 liters for the blood plasma, and then 30 to 50 liters is the range for the total body water, and then something beyond that is basically body fat and other tissue compartments. So here it is 280 liters, which is beyond the 30 liters, 30 to 50 liters range, that is for water, or much beyond the plasma volume, which is around 8 to 10 liters. So these drug is going to, it also says it's a lipophilic, highly lipophilic compound, right? So it's going to get accumulated in the body fat mostly, and some other lipophilic tissues. So that will be the correct answer. First part of the answer will be 280, and the second part in total body fat. Okay, we have another numerical here. A polymer is made up of the following composition: 5 moles of molecular weight 20,000, 10 moles with molecular weight 50,000, 15 moles with molecular weight 80,000. What is the number average molecular weight of the polymer? A polymer is made up of the following composition: 5 moles of molecular weight 20,000, 10 moles of molecular weight 50,000, 15 moles of molecular weight 80,000. What will be the number average molecular weight of the polymer? Okay, two people have answered 60,000. Anybody else? What is the number average molecular weight?
60,000.
Okay,
60,000.
okay. Okay. Yes, all of you are correct. It would be 60,000 gram per mole. So the formula for number average molecular weight is basically summation of number of molecular weight into number of moles, summation of ni by summation of ni, or the total number of moles. So it will be, the top one will be basically 5 into 20,000 plus 10 into 50,000 plus 15 into 15 into 80,000. That will give you approximately 1800,000, and then the total number of moles, which is 5 plus 10 plus 15, which is 30. So this will give you 60,000. Okay, so the number average molecular weight is 60,000. Okay, moving on to the next question. A drug is being eliminated from the patient's body at a rate of 24 mg per minute. At that moment, the plasma concentration of the drug is measured as 8 mg per liter. Calculate the clearance rate of the drug in liters per minute.
And 3 liters per minute.
Okay,
Ma'am, 3 liters.
okay,
3 liters.
okay.
I remember.
Anybody else would like to answer?
3 liter per minute.
Okay. Okay, here also people have answered. Okay, yes, most of you, all of you are correct. It will be 3 liter per minute. So the to calculate the clearance rate of the drug, basically it is the rate of elimination, which is uh, 24 mg per minute, and the plasma concentration of the drug, which is 8. This will give you 3 liter per minute, which is the correct answer. Okay. That was all the questions I had for today. If there is any other doubt or any other questions that you want me to repeat again, we can go through it again. Let me know. And yeah, otherwise, we'll see you next week.
Ma'am, every week we have one lecture video, right?
One lecture video, as in one session.
Yeah, every week we have only one session, right?
Uh, no, there will be three sessions by three different people. One is on Monday. Uh, I am not sure. I think you guys would have, they would have shared the session dates with you.
Yes, ma'am.
Yeah. For those who joined late, let me know if you want me to start over again. Yes, I'll go through the questions again. Okay. So this was the first question that we discussed today. A prodrug can be, which of the following two options are correct for a prodrug? A prophylactic drug, drug conjugated to enzymes cleavable by biological systems, prototype member of a class of drugs, oldest member of a class of drugs, or inactive drug that is transformed in the body to an active metabolite. So among these options, option 2 and 5 are the correct answer, which is drug conjugated to enzymes that is cleavable by biological systems, and an inactive drug that is transformed in the body to an active metabolite. In both the cases, the drug becomes available only inside the body after some action, and then only it becomes an active metabolite. So that is the definition of a prodrug. Moving on to the next question, which of the following drugs are absorbed in the greatest amount? So here these were the different options. 100 mg of the drug administered with bioavailability of 0.7. This will amount to a total drug absorbed 70 mg, that is basically 100 into 0.7. for 150 mg of drug administered, bioavailability 0.5 will give you 75. 200 mg of drug, bioavailability 0.4 will give you 80 mg. 250 mg of drug administered, bioavailability 0.2 will give you 50. 80 mg of drug administered intravenously, since intravenous is 100% bioavailable, 80 mg will be available. And then 80 mg of the drug administered orally, and then 20 mg given orally, 20 mg given intravenous. If you compare across all of them, option 3 has the highest amount, 80 mg, as well as option 5, another 80 mg. So option 3 and 5 will be the correct answer, which is these two dosing are absorbed in the greatest amount, 200 mg of drug with bioavailability 0.4 and 80 mg of drug administered intravenously. Moving on to the next question. New antiviral drug is administered intravenously, resulting in an initial plasma concentration of 12 mg per liter, and after 9 hours the plasma concentration is 1.5 mg per liter. So assume first order reaction, elimination kinetics, and calculate half-life of the drug. Here we'll use the first order elimination kinetics equation, which is Ct equals to C naught e to the power minus Kt. Ct here is our concentration at time t, which is 1.5 mg per liter, and C naught or initial concentration, which is 12 mg per liter. K here is unknown and t here would be 9 hours. So using this equation, it will be ln 1.5 by 12 equals to minus K9, which will give a value of 0.231. Now to calculate the half-life of the drug, we have to use the equation 0.693 upon K, which is 0.693 upon the K that we got from here, 0.231. So it will give a half-life of 3. So that this drug has a half-life of 3. Next question was volume of distribution or VD of a drug is known to be 30 liters. How the drug is expected to distribute in the body. So the total volume of the drug, so there are different fixed amounts, fixed range of volume for different compartments of the blood or body. Blood, for example, is approximately 5 to 10 liters. Total body water is approximately 30 to 50 liters. And then fatty acids, total fatty tissues and other tissues amount to more than this 50 liters, basically let's say 200 to 1000 liters basically. Please feel free to stop me anytime if you guys have any doubt, otherwise I won't know. Okay, so if here the volume of distribution is known to be 30 liters, and since we know that the total body water volume is approximately 30 to 50 liters, so the correct answer here would be option 2, in total body water. Moving on to the next question. Which of the following equations depict a second order reaction? Here you have to select two correct options. Here option B and option C will be the correct answer. Option B, where there are already two components, K, C1 and C2. Option C has K, C1, C2 to the power 0.5 and C3 to the power 0.5. This will be basically C1 into C2 plus C3 to the power 0.5. Again, there are two components, so this will also form or depict a second order reaction. So option B and C will be the correct answer. That is, both of these are second order reactions. Next question was, which one of the following will have ease of permeating through cell membranes? Drugs with higher partition coefficient and is highly polar, high partition coefficient and not polar, lower partition coefficient and not polar, lower partition coefficient and highly polar, hydrophilic drugs, highly charged drugs, or polar molecules. So partition coefficient is basically the solubility of the drug into immiscible liquid, basically in oil and in water. Oil upon water. So cell upon water. So since the cell membranes are lipophilic, it will it needs drugs with more dissolved in oil phase or high partition coefficient, and it should not be polar. So option 2 will be the correct answer, drug with high partition coefficient and is not polar. That will have the that will be easiest for permeating through the cellular membranes. Next question was about the bioavailability. Which of these options define bioavailability? Here the correct answer would be option 1, which is area under the curve for administration through any route upon area under the curve for administration through intravenous route. Next question was, a 75 kg patient is administered a single intravenous dose of 280 mg of drug and a highly lipophilic compound. After distribution equilibrium, the drug's plasma concentration is measured as 1 mg per liter. So you have to calculate the apparent volume of distribution of the drug in liters, and based on this VD, what do you think, where do you think the drug is getting distributed? So as I previously mentioned before, there are fixed range of volumes for different compartments in the body. So first let's calculate the volume of distribution. That will be total amount of drug in the body by plasma concentration of the drug, which is 280 mg by 1 mg per liter. This will give us 280 liters. Now 280 liters is beyond the 30 to 50 liters of range for total body water, as well as beyond the plasma, which is approximately 5 to 10 liters. So this 280 liters means that the drug is getting accumulated in fatty tissues, in total body fat or in other tissue compartments with fat. So this will be the correct answer, 280 liters and in total body fat and other tissue compartments. Moving on to the next question. A polymer is made of the following composition: 5 moles of molecular weight 20,000, 10 moles of molecular weight 50,000, and 15 moles of molecular weight with 80,000. Here you have to calculate the number average molecular weight of the polymer. The formula for the number average molecular weight of the polymer is summation of MI/NI by summation of NI, where MI is the molecular weight and NI is the number of moles. So summation of MI/NI is basically 5 into 20,000 plus 10 into 50,000 plus 15 into 80,000, which is basically 1800,000, and total number of divided by total number of moles, which is 5 plus 10 plus 15 is equals to 30. This will give us 60,000, which is the number average molecular weight of the polymer, 60,000 gram per mole. The next question was, a drug is being eliminated from the patient's body at a rate of 24 mg per minute. At that moment, the plasma concentration of the drug is measured as 8 mg per liter. You have to calculate the clearance rate of the drug in liters per minute. So that is basically the drug elimination rate, which is 24 mg per minute, upon the plasma concentration of the drug, which is 8 mg per liter. This will give you 3 liter per minute, which is the clearance rate of the drug. That will be the correct answer. So that was all the questions that I had for today. If you have any doubts, please let me know. Or if you want me to go through any question again, let me know. Otherwise, see you next week.
Thank you so much, ma'am.
Welcome. See you next week.
Yes, ma'am.
Anybody has any doubts? Thank you for joining, everyone. If nobody has doubts, then we'll close this session here. If you can leave the session if you don't have any doubts.